Yes, I'm going to go to the open part here. Oh, I probably have to check my project first. You could also do this if you want to. As you can see, now I'm in the 2A project because I was doing this lecture yesterday for Group A. So I have to move to my 2B project. Then I go to the open up there. And I have a file name here, which is plate with holes, but I don't have any holes in the plate, so we have to fix that. So press the OK button, and it should open up. A bit slow today. So I want to look at my plate from the top. I'm going to turn it around here. So now I'm looking at it from the front. I'm going to flip it further here and up to the top so that I get it like this. Have it up like this. And we're going to create the holes here. And in order to create the holes, we are going to use the fabulously named function of hole. And this one has a couple of different options for placement of holes. So if you have a pre-drawn sketch where you have placed points where you want the centers of the holes to be, you can choose from sketch, and then it will just place holes on all of the points inside the sketch. You can also choose to give it linear position for the center of the point, so then you will basically give it an x and a y coordinate. You can choose to have it concentric, which means that if you already have a circular feature, you can place the hole with the same center as that circular feature. So if you have a cylinder and you want a hole at the end of the cylinder being directly in the center, you can use this one. And on point, that's a bit more advanced than we're going to get into, so we're not going to look at that one. We're going to choose the linear one for this one. So the first thing inventor wants us to choose here is face. That just means the surface that we want the hole to start on. So we choose the front of the plate, or the top in my case. I'm also just going to tilt it a bit so that you can see a bit better what's happening here. Move this one off. So now I've chosen this surface on my plate. And now it wants me to put in a reference. So I'm going to choose one of the edges of the plate. So I choose the bottom edge. There. As you can see, it wants me to give a distance from the bottom and up to the hole. And what it says on my drawing is that there is supposed to be 20 millimeters from the bottom and up to the center of the lowest hole. So I put in 20 for that one. But don't push the enter button or anything, then you're going to just create a hole right there. We want to put in the second reference also first. And then we'll choose the side edge of the plate. And now it wants us to give the distance there also. And what it says in the drawing is that it's supposed to be 20 from the side edge and into the center of the corner hole. So we put in 20 for that one also. So now we just need to look at the kinds of holes we have in this plate. And for this plate, it is really easy. It's just a regular hole straight through. But we have several options we can choose from here. So you have the top option here, which is the regular hole, which is the one we have marked now. You also have one that's called a counter bore, where you will have the start of the hole will have a bigger diameter than the rest of the hole. And that is so that you can sort of hide the head of a bolt inside this counter bore if needed. If you need something to move flushly against the surface there, then you don't want the head of a bolt sticking up, so then you want to lower it into the material instead. Spot face is basically the same, but it's more used that if you have a curved surface, you use spot face just to make a flat area for the bolt head to rest against. And then you have the counter bore if you have a conical head on your bolt. So then you use those. In this case, we're just going to use the regular drilled hole, so straight through. You also have a couple of more options down here where you can choose to have a tapped hole, where you have threads, internal threads in the hole. We're not going to do that now. For termination, we're going to use through all in this case, because then it will just run the hole straight through our plate, all the way through. If we wanted the hole to go just a couple of millimeters into the plate, we would have chosen distance instead, and then we would have set the exact distance for the hole to enter. And then we have the option up here to give the diameter of the hole. And in the original drawing we have for this one, it says R10. So a radius of 10. And if you don't want to do the maths in your head here, you can just do 10 multiplied with 2 to get the diameter. Then we can push the apply button. You can also push the OK button in this case. You don't have to push the apply button first. This is one of those inconsistencies that is. If you're going to mirror something inside a sketch, you have to push apply, but if you're going to create a hole, you don't have to push apply, you can just push OK. So, so now we created the very first hole here. We could repeat the process for the remaining 7 holes if we want to, but I want to show a different way of doing them. So first off, we're going to use a pattern to create the 4 holes on one side, and then we're going to use the mirror function to put them over on the other side. In this case, you would most likely use approximately the same amount of time, whether you do 8 holes individually or if you do these patterns. But if you're suddenly working on a fairly large structure and you're going to put in 80 holes in a pattern, then you really want to use the pattern function. You don't want to do 80 holes individually. So that's why I'm showing these functions. So we have pattern up here, up there. I'm just going to move my stuffer a bit so I'm not. And then we have this one up here which says rectangular pattern. We'll choose it, and it opens up this window. And the first thing it wants us to do is to select the feature, and that's the hole itself. And then you can either go into the 3D model until the hole is marked there, or you can also go over to the tree here, the browser tree, and choose hole 1 there. And then you see it also lights up in the 3D model. So if you have difficulties selecting it in the 3D model, you go to the browser tree and select it there. And sometimes if you want to select larger patterns, it might actually be easier to select them in the 3D model. So it's a bit back and forth there. Just see what's the best one. Then we have the options of giving 2 different directions for the pattern. So we can create a replication of the hole in one direction and then replication of those holes in a second direction. So we'll start off direction 1. I'm just marking this button right now. And then I choose the lower edge here, because that means that my 2 holes will be along the same line as that edge. And I was put in the outline of a new hole there just to show me that that's where I'm putting it right now. I also have this arrow telling me that it's going this way. And that's the way I want it to go. And I also want there to be 50 millimeters in space between them. So instead of 10 millimeters, I want 50 millimeters. So I go up here and I put in 50 millimeters. And this looks about right. If we look at this plate, looks fairly okay. Then we choose direction 2. Now we're going to choose the vertical edge of the plate. So I'm choosing this one. But now you can see it wants to put them downwards instead of upwards. And I don't want that. So I'm going back into the window here. And then you see we have this flip switch there. So when I choose the flip switch, it flips the direction of the arrow. So now it's going the correct way. Still I have 10 millimeters, which is the default setting. That's too little in this case. So I look to the original drawing, it says 70. I change it into 70. So then I get a rectangular pattern with 4 holes. And I press OK. So now I've placed all of those holes. But now we only have them on one side. We want to mirror them across to this side also. And it's basically the same as we did for the sketch, only now we're going to choose the holes instead of choosing the lines that we're going to mirror. And even the symbol looks more or less the same, as you can see up there. That's the mirror function. This time we're not going to use the symmetry line to mirror it. We're going to use one of the planes that is moving straight through the plate here. And this is because when I constructed the plate in my sketch, I made sure to place the center of my coordinate system in the center of the plate, which means that I have all of my axes are going through the centers of the plate here. So choose the mirror one. It wants me to select my features first. So either I can select hole and rectangular pattern out in the browser there. So I have to hold my shift button to select shift or control to hold to select several, or I can move over here, and if I choose one of the 3 holes that the rectangular pattern created, it will also include the original hole. So I click that one. Now they turn blue, so those are the ones that are going to be mirrored right now. And now I have to specify a mirror plane. So I click this one, but I can't see any of my planes right now. I could see them when I put the first sketch in, but I can't see them anymore. So I have to go into my browser tree here, to the origin folder. And as you can see, the different icons here are grayed out. That's because if I right-click one of those, I can't do it when I'm doing the mirror function. So if I right-click one of them, you will see that the option of visibility has not been checked. So if I want to, I can check it, and then the plane is visible again. But as soon as you have put the first sketch into place, the visibility of your planes will disappear. It will automatically be removed. So if you want it to remain, you have to manually set the visibility. So I'm going to remove it again because we don't really need it, because we can find everything we need here in the browser tree. So I'm going back into the mirror feature there, selecting my mirror plane, and then I'll have a look at the different planes there. So we have the XY plane. It's going horizontally through my plate, so that won't be correct. The XZ plane is going along the surface of the plate. That's not correct either. And then we have the YZ plane, which is going straight through the middle vertically. And that's the one we want to mirror it across. So I select that one. And you can see the preview of the 4 new holes. And when I push the OK button, they're placed in there. So again, compared to mirror in the sketch where you have to push apply before you push OK, here you don't even have an apply button, you just push OK. I don't really understand why they're doing it this inconsistently, but that's what they do. So now we've gotten all of the holes into place, and we can start creating our drawings. So I think we'll create a drawing for this one first, since we're in this project right now, and then we'll go back to practice task 1 and create a drawing for that one afterwards. So I click the save button just to make sure I've saved it. And then I go up to the corner there for the new button, and I press new. Again, we have to choose the metric folder when we're going to create a new file. So metric to get the correct files to look through. And we have to scroll down a bit here. So here in this area we see the drawings, different kinds of drawings that can be used. There are 2 different kinds of files. There's DWG and IDW. DWG is the one that is used by a software called Autodesk, and it is also used by not Autodesk, but AutoCAD. And it's used by a lot of other softwares also. But we're going to use the one that's called IDW, which stands for Inventor Drawing. And we also want to use the one that is named ISO. So we choose ISO, IDW, and then create. And notice that I haven't closed the part file. It is open down here. It says plate with holes.ipt, and I have drawing 1. Just let people catch up a bit here.
What's the number? Yeah, just scroll.
Oh, yeah.
So you double this number.
You just start the sheet, paper design, and then you do metric, and then you scroll down, and then ISO.IDW. Just that. Then
Make it. Press it. How long does your line?
It's the one that's called ISO.IDW. No? No? ISO.IDW.
Now you made a new line because you're right.
No, you have the DWG file. So you just close it. Right, then we're going to place our part into our drawing sheet. But I saw that some of you don't have the part file open. So you need to open your part file as well, because it needs to be open in order for the drawing sheet to recognize which one you're going to put in. If you don't have it open, then you have to actually go into your file browser, and then you have to choose the correct part file to put in. So it's a bit easier if you just have it open in Inventor. It will be automatically selected when you're creating the drawing. Yeah, you put the drawing in there, then you can just push open if you want to open the file. You're in task 6.
Yeah, I just tried.
Oh, you've drawn it already. Yeah. But then if you just want to see what I'm doing, then if you're not going to actually do it, then it's fair enough. But it's a bit easier because if you have the part file also open here in another tab, then when you're putting your base view in here, then Inventor will automatically choose the part file that you're using last. That is so you can have many part files open, and then the one that you were in last doing something in, then that one's going to be put in. Then you have to go to the correct folder and have a file. You're going to have a problem with the projects now if you have a set of different projects. One down. If you click it, then you will see a preview there. You can do that with the green. I think if you scroll a bit, there you have task 2. Yeah, that's right. So if you just do open on that one. Yeah, because now drawing. It's just telling you that it's not finished. It's not in the same project. So just locate it. They're not going to automatically find each other. But we can move the drawing file afterwards. So you can move it from your folder of task 6 to the folder of task 2.
I don't know where you
Should be on your H drive. If you're going to be able to find it on all your computers, you have to do it on the H drive. Fine. Okay, in order to start with our drawing, we need to use the function that is named base view up there. So we click on base view, and what you will see now is that it has automatically chosen the IPT file that I have open in a different tab here. So that's why we want it to be open, because then it automatically chooses it. We don't have to go into our file browser and try to find the correct file and stuff. So it's a bit easier that way. Now it looks a bit. Now we're looking at it from the side here. So it's we think we're looking at it this way. We don't want to look at it this way. We want it to be like this in the drawing. So then we can use this view cube and we can start rotating it. So if I click at the top there, you see now I've put it at an angle. So I put top there, and now I'm looking straight at it from the top. So straight at it like this. But the scale is a little small. We could do it a bit bigger, just to fill in our sheet a bit more. We don't want a lot of blank space in our sheet. So I'm going to check how the scale of 1 to 1 is going to look. That looks fairly well. We can use that. We're going to have room enough to put in our dimensions here. We also want to put a secondary view over to the side here, because we want to be able to see it. We want one view like this, and then we want to flip it so that we get a projected view here, looking in at the side, so that we can set the thickness of the plate and put a dimension on that. And then I'm just moving my mouse pointer over to the side here, and you can see the green dotted line showing where it's going to place the projected view. So I click once with my mouse pointer, and then I get it placed there. Now all I need to do is to press the OK button, and then I can move it afterwards. Dra på nedover oppe. Dra på nedover oppe imellom. Dra på nedover oppe. Tidligere. Nei, jeg har tatt den ned. Then we click OK, and now it's placed here. The thing is that it's now placed, my base view is placed in the center of my sheet. But I don't want it to be in the center of my sheet. I want to move it a bit more up to the upper corner here. So I'm going to place my mouse pointer where it shows a red dotted line around it. Then I'm going to click once. So now I've selected the base view. And then I move my mouse pointer so that it's here on the red dotted line. And now I can click and drag. So I click and drag, I move it up towards the corner. And you can see the projected view was also moved up because of this. Because the projected view has to stay in line, in a horizontal line with the base view. I'll just leave the projected view over here to begin with. We'll set our dimensions and stuff first so that we can see how much room we have. There is one thing I want to do though. In our base view, in our projected view over on the side here, we can see hidden lines showing the holes. Now we are giving all the information needed for our holes on this view, so we don't need to show them in this other view. So we're going to double click it, put the mouse pointer over it so you get the red dotted line, and then we double click. So we open up this window. We have to do it on the base view actually. So we have to double click on the base view, this view, and we have to choose a different style for it. So the one that's marked blue right now is named Hidden Line, and the one next to it is named Hidden Line Removed. So we're going to choose that one. And then we click OK. Yeah, you'll have to get help from the assistants then. So now you can see in the projected view here, the hidden lines for the holes have been removed. So we can't see them anymore. So now we're going to start putting in dimensions. And then we need to go all the way up and choose a different toolbar. So up top here, all the way up to the one that's called Annotate. And we click the Annotate tab there. So we get the Annotate toolbars. And the one that's simply called Dimension is the one that we're going to use to set our dimension. So we choose the dimension function. Right now we want to just give the dimension of the entire plate, the length of the plate here, and we're going to give some of the heights also. So when I click directly on the line that's marked with the red right now, it's going to dimension the entire line when I'm putting this one in. So clicking this one, pulling down, and we can see where it wants to put. And Inventor wants to is showing this one with dotted lines right now because it wants to lock it into place right there. But there's one more thing that we can notice, and that is that we have a .00 on it. So 0.00. We don't want that. We just need it to show 210. We don't need to show any decimals unless there is something else than a 0 there. So what we're going to do is we're going up to the Format part of the toolbar, and we're going to choose Default Method 1B. So this one, Default Method 1B. So when I come back to my dimension here, it now says 210. If it had been 210.2, it would have still shown 210.2. But if I hadn't fixed the formatting, it would have said 210.20. So we don't want it to show unnecessary digits there. So I place the dimension, I get this window up, and we're going to look a bit more at this window later on when we're going to put more information into it. But so long as we only needed to show the exact dimension, we press OK. Because we don't have anything more to add to that one. The next dimension I'll be putting in is for this line going up here. And again, I can just put my mouse pointer across it so that it turns red. Click once, and I pull my mouse pointer over to the side. And as you can see, now it's not showing 0.00. So now it's already chosen the method 1b. But if I had exited my dimension function to do something else and then want to do a new dimension, then I have to redo the method 1b. So I'm going to put this one into place. I'll press the OK button. The next step will be to put the entire height of the plate in. But I don't have a single line going from bottom to top, so now I'll have to do it the dimension between two lines instead. But just to show you that the method 1b formatting is going to disappear if you exit the dimension function, I'm going to do that first. So I right click and press OK. Now my dimension function isn't marked blue anymore. So if I reselect dimension now, it once again says standard in the formatting. So I'm going to change it to 1b before I set my dimension. And now I'm going to click on the lower line, on the bottom of the plate, and then on the top of the plate. And I'll move the dimension over to the side. So then we get the total height of the plate. And I click the OK button.
So what you can do is you can do like this first. Is it after? So just click it. On the screen, you go there. Click 1. Or when you do it, you can press dimension. And when you do it, like it says 3.00. Instead of pressing, just go up there. Choose 1B. Like it. Okay? So you can do it two ways.
So now we're also going to put in the thickness of the plate on the projected view here. But then I'm also going to show you how to fix it if you forgot to do the method 1b when you put the dimension in. I'm going to show you how to fix it afterwards. So I'm going to exit my dimension function just to reset it to standard. When I select my dimension function again it says standard there. And I'm going to put it in for the bottom of my projected view here. It is often good to just zoom in order to get small lines. You can also zoom out before you place the dimension. So now I've placed the thickness of the plate. Just going to zoom into the corrector. But I've forgotten to do the method 1b here. So what I do then is that I exit the dimension function. Make sure that it's not marked with blue up there. Then I click the dimension in question, in this case the thickness of the plate, so that it turns red. And then I can change the format afterwards. So I can do format, method 1b, and it changes to showing just 5 instead of 5.00.
If you've done it right, you can choose this and everything will this time. You want me to show you quite fast how to do it?
You want to do the token, so you press this lower one, then the top, and you pull out.
Now it's moving down, so you have to press filter.
Okej. Det kommer att säga, det tar jag alldeles för.
Then you have to change what is the distance between the holes.
Bara det upp och så visar den på
70, then you have to write 70. Yeah. Then you have the mirror. Yeah, correct. So features. So you have to choose the holes. You have to press again because this one's to be pressed. Now what this one?
This one?
Yeah. Yeah. Now it's on. You have to choose the holes. Yeah. Press. Okay. Now choose the holes. Mirror plane. Yeah. And then you go to origin. You press the arrow. Press the arrow. There it is. Then you have to choose one. Okay. That's the correct one.
Is it
Yeah,
not
because
easier
of the mirror.
than doing everything by hand?
Then okay.
And you'll have to do this one.
Choose the face, group one.
That's good.
That's fine. Just bring it right down.
Probably in here.
Now we touch the face. But this only I chose you where it's up. So let's use the reference. That hole, that edge is supposed to be 20.
So we could continue on with doing dimensions for the slot on top here, and a few other on top, but we can't do all of the dimensions now because we have no way of dimensioning the holes. We have no center marks going through the holes. So we're going to have to put the center marks into place.
The cutter function. Rectangular cutter.
And when I go up to this function up here, it's under these symbols part of the toolbar. We go to the center mark function, click that one, and then you can just select all of the holes. So all of the holes are to have a center mark.
Distance, I don't remember.
And when you're done putting in all 8 center marks, you can exit the center mark function.
Okay. Now?
Now when we created the 3D model, we made use of a symmetry line, which means that we need to show the symmetry line in the drawing also. We go up to around the same place where we found the center mark. We go to the function directly above it, which says center line. And for Inventor, there is no difference between symmetry and center lines. It uses the same function for both. So we choose the center line. And you can either move your mouse pointer until you get the green point showing the midpoint of the bottom line there, or you can just choose the bottom line anywhere you want to, because it's going to put it into the center anyway, and then put it up to the bottom of the slot up here. Once you've selected those two, it is possible to continue selecting lines, but we're not going to do that in this case. That's the reason why it's following my mouse pointer around here. So instead I'm going to push the right mouse button and do create, because you're not done placing the center line until you've done the right mouse button and create.
So that's a big advantage.
What this center line is now telling us is that we have a plate that is 210 millimeters wide, and that it's equal on both sides of the center. This means that I can put dimensions on the holes on one side of the center, and I don't have to do anything on the other side because those will be symmetrical. But we're going to need some room here to put in the dimensions for the holes, because those dimensions will be smaller than these and we don't want them to be crossing over other dimension lines. So I'm going to click on the already placed dimensions here, and I'm going to just move them off a bit so that we create some space. So I mark the dimension so that it turns red. We get this moving symbol, so I can click and drag it. So I just move it off quite a far a bit here. I'm going to move it back afterwards. And I do the same with the other dimension here. And the same with the bottom dimension. And now I can start putting dimensions to show where the centers of the holes are supposed to be. So I choose the dimension function. And I switch from standard to method 1B. And I want to give the placement of the holes with regards to this edge and the bottom edge. So I'm going to do the horizontal dimensions first. So I'm going from the side edge. And then I'm choosing the center mark itself and pulling the dimension down here. Press OK.
If I stand here and I want to move myself this way.
Choose the side plates. And then the next center mark here. And put the dimension in place there. When we are looking at this drawing now, it is fairly obvious, even to the naked eye, that the holes on top here are placed on the same vertical line as the holes on the bottom. So you don't need to dimension the top holes. You only dimension the bottom ones. And we're going to do the same for the vertical dimensions. We're going to dimension the ones the holes that are far to the right, and we're not going to dimension this hole at all, because it's being given by the others. So we click the bottom line and then the center mark of the first hole. Move the dimension off to the side. Click OK. Then we are going to do the same, the bottom line and then the top hole. I hit it incorrectly here. So I have to do dimension again. Switch to 1B. Here. And to the center mark. So what it wanted to give me when I did the incorrect dimension there was that I clicked the bottom line and then I hit the vertical part of the center mark. So then it wanted to show me that it's 90 degrees between these two lines. So we have to hit the horizontal part in order to get the dimension between them. Now I can move these dimensions back into place, so closer to the others. And I'm going to put just a few more dimensions on it before we do a 15-minute break. click the dimension function, remember to change to method 1b. Now I'm going to give the width of the slot up here.
The most used or the most used scales
I also need to give the depth of the slot, and that one is a bit tricky because if I choose this edge and I place the dimension out here, I'm going to have a dimension line passing through all of this, and then I'm going to have dimensions lines crossing each other over here. That's going to be just really messy when you're trying to read it. So I'm instead going to place this dimension inside the slot itself. So I click on the edge, and I place the dimension inside the slot, because that will actually be less messy to read than pulling it out to the outside of the parts. We still need one more dimension in order to cut this plate into its correct shape. Two more dimensions we need. We need to know either how far is it from this edge to this point, or the length of this bit. So we need to know something there that gives us the length of the angled line there. And we also need, of course, to know the diameter of the holes. So we're going to do the slope here first. One way of doing it is giving from this point to that point, because we are giving that dimension across a symmetry line so that we know that this will be situated in the center of our plate. So if I put it from here to here, and I put the dimension on top there, now I hit another symbol here, so. And then I push OK. If you choose to put it from this edge and over to there instead, that's not a problem, because that's going to give you the exact same effect when you're creating the plate. So it's really more a matter of how you want to read your drawing. And then we need to put in the diameter of the hole. And here we have a nice big open area. So I think I'm just going to put it on this hole, and I'm going to drag it over here to show the dimension. So I click on the hole, and I pull it over here. And it automatically chooses the diameter symbol, and it sets the dimension for me. So I don't have to do anything there. It's the same if you choose a curve, a radius, it will put a capital R in front of the dimension automatically. Then we do a 15-minute break. Right, then we're back here. So now I'm going to just show you a bit practically why I'm putting the thickness dimension of the plate here. Because now the plate is 5 millimeters, so I'm going back into my 3D model and I'm going to change the thickness of the plate and just show you that it's going to automatically update on my drawing. So I go to my plate part down here. I click the tab so that I switch back into this one. I'll go to the original extrusion that I created, which gave me the thickness of the plate. I double click it. It says 5 millimeters, which was supposed to be the thickness of the plate. I'm going to put in 15 now. And then I'm going to go back into the drawing here. Click the tab. And now you see it says 15. So now it's been automatically updated in my drawing. So that's the whole point of doing it. If I had just done text and written in plate thickness 5 millimeters here, so when I then fixed the 3D model, I would have made sure to remember to go in here and fix the text afterwards, because the text is a manual thing. But as soon as I have the dimension put in place there, then it's going to be automatically updated. I'm just going to return it to the original here, 5 millimeters. So we have all of our dimensions in place in order to create it, but we're going to need some more information. So there is some information we need. We have said that the diameter of the hole here is 20 millimeters, but we've only put it on one hole. We're not showing it on several holes. So one way of doing this is to add behind the text here, I can add tip in a parenthesis, because that means that this dimension will be typical. So all other holes that haven't been given a dimension will have this dimension. So then I've shown it with a typical dimension of 20 millimeters for the holes. Then this one is going to go for all of them. But there is one other way of doing this, which is even more automated.
Shows you what it's.
I haven't done much, I've just written tip. You double tick it and it's like, but there is one other way of doing this, which is even more automated than this. So I'm going to show that one also. And it's using hole and thread instead of regular dimension. When I click hole and thread, so I'm going to just put it on this hole instead here. I have to switch to method 1B, as usual. And when I place this dimension, it says that it's going to be 20 millimeters across, and it's going to go through the plate. So it's going to go all the way through. So this one is actually telling me that the hole is going all the way through. And what I can also do now is exit the hole and thread function. I can double click it to go into this one, and you see it's already putting in a lot of the information here. It has the diameter symbol, and it's auto-filling in the dimension of it. And then it has put in through behind there. I can start a new line here, pushing my enter button, and then I can go down to this one, which says quantity note. So I hit this one, and I press OK. And now it says that there are 8 times this hole. But as you can see, we are putting it below the text there, so it might actually be either better to do either we could write 8 times hole beneath there, or we could actually put the entire thing in front of the dimension here. So if I move it all the way to the front, and then I put the quantity note in, press OK, and then you'll see it'll show me 8 times a diameter of 20, and it's going all the way through the plate. So this is giving me even more information than what this one is doing. So I'm going to remove this one, because we don't need to give the same information twice in a drawing. We want to avoid that, because it could create confusion in whoever's going to produce the plate. So now we have all of the dimensions that we need. But we also need to know something more, because when they are creating a plate like this and cutting it, they won't be able to create it exactly 210 millimeters width. They will need to know a tolerance that they can stay within. So we will need to give them information about a general tolerance. And the information about the general tolerance we have to do manually. There's no automatic stuff in that, at least not yet. There might end up being that sometime in the future, in a future version of the program. But we go up to the big capital A there, which says text on it. Select that one. And now we can just place a text box with our mouse pointer. So if I just click here now, I open up a window where I can write some text in it. And what I'm going to write in here is that I'm going to write the general tolerances and surface finish. and I'm going to put in some information on which standards they're going to follow when they're doing it. So general, tolerances, and surface finish. And the general tolerances. You have a question? Yeah. Yeah, you have to exit this one. So either right click and okay, cancel, yeah. Then you double click it. And you place the marker in front of it. Either use arrows and then you click that one, the square. One keynote. Then press OK.
Yeah.
So now it's going to say 8 times. Because now it's inventor is counting. You made one row originally, but then you made a row after 4, and then you mirrored it, so now you have 8. So it's going to be 8.
Now you will rearrange the dimensions.
Yeah, that's the text function. And then you just place it somewhere. Okay, we're going to have to move it afterwards because we don't know how big the text is going to be. Yeah. And then you have to switch it to the 1B just to get it a bit easier to read. Now you can just drag it from the outside. Now you have to drag it between a circle there. Put your mouse over that one. You have to get that symbol on your mouse pointer. Good there. Yeah, you haven't used the through function, so it's not going to go through. You put in a distance of 5 millimeters to send through. So that's why it's showing you that it's 5 millimeters deep, but your plate is also 5 millimeters thick. It's going to go through. The information is basically the same. So you don't need to do anything there, but what you need to do is from there you add this one, which is quantity notes. Then you will get 8 times.
From here to here will be
Yeah, okay.
it will be 40,000.
8 times 20, and they're going to be 5 millimeters deep, but the plate is 5 millimeters thick, so then they're going to go all the way through. And then you have the text box up there. Start it up. So place some of those. And for the general tolerances, yeah. Yeah, it's just going to be that one in which is same that it doesn't really matter whether it says so whether it says that also all the way through or if it's going to 15D1. If it says 15D there and it's still going all the way through, so it's not a part that says
Yeah, okay.
Yeah.
Somewhere around here, maybe, because we have to do that.
You have 20. It's plus or minus 2.1.
So we're going to fill in which ISO standard we're going to use here. So ISO 2768-1. This ISO standard gives us general tolerances for length dimensions. And we're just going to use medium. So this one you would set as fine, medium, coarse, or very coarse. So F, M, or C, or B. The usual one is to choose medium, unless you have some particular reason for choosing another one. The next one, the next standard gives us more for perpendicularity and straightness and cylindricity and stuff like that. So we put in ISO, still 2768, but now it's -2. So now it's part 2 of this standard. And this one is given with capital letters, and they are not fine, medium, coarse, and stuff like that. So the one that is corresponding to the medium one is a capital K. So we put that one in. Actually, I see I put in fine on this one in the practice task, so I'm going to put that one in. We change it from medium to fine, F. F for fine. And then the equivalent of fine is L, I think. No, H. A capital H for that one. The text is also in your compendium, so you can write it up from there. Because now I'm going to push the OK button, so it's going to become a bit smaller on my screen. So here I have the text box. And my text function is still marked with blue up there, so I'm going to right-click and press OK, just so that I've exited the text box function. So now I can mark the text box, and then I can drag it. Det står i boka om man har gått gjennom det. Så, ja. Det var det vi gjorde den første veka. And then we just drag it down to put it on top of the title box, the title border. I've also written in surface finish here, so I need to add a symbol to show which surface finish we're going to have. So I go up to the symbols part of the annotate toolbar, and I choose the one that is named surface. And then you can see I get this sort of check mark on my mouse pointer. And I'm going to place that check mark beside the text there. And this one is a bit more involved when you're going to put it into place. So you click once with your left mouse button, and then once with your right mouse button, and then continue. Then you will have it into place there. Here we have a few different options on what to do. So we have surface type. If we keep this one selected, the basic surface texture symbol, it means that we really don't care how the specified surface finish is attained. So if this plate already has the surface finish, it's okay to just not do anything with it, just keep it as it is. What we can also do is choose this one, removal of material required. Then we're telling the manufacturer that they have to do something with the surface. They can't just keep it as it is if it's good enough. And the third option is removal of material is prohibited. So if you, for an example, want to use a regular pipe that you bought, you need to do something to the inside. Maybe you're going to put a piston in there or something, but you don't need them to do anything on the outside. The outside can be as rough as it is, straight from the rolling mill. Then you choose to use this on the outside surface of the pipe, because then whoever is manufacturing this cylinder won't do anything to the outside. In this case, we're going to tell the manufacturer that they have to remove material. So removal of material is required. And we are going to specify the surface finish. And we do that in the A field over here. And we're going to put in RA. So a capital R and a lowercase a. And 6.3, which is a sort of medium surface finish when you are machining a plate. So this means that since we have a medium surface finish and we've told them that they have to remove materials, they can't just take a 5mm plate, a plate that is 5mm thick, and just cut it. They actually have to do something to this surface. So they have to move it, put it in a milling machine, and do something to it. When we press OK, the symbol is down here. It has all the information that is needed. But we also need to know what kind of material is the plate to be made from. And in order to know that, we have to put in a parts list and we have to modify it. Because usually a parts list is used to show which parts are going where in an assembly. So you would have several parts and they would be numbered 1, 2, 3, 4. And you would use the parts list to give clarity to which part is which. In this case, we have only one part. But we want to show the material that we set when we created the plate. And I'll actually check if we remember to do it. And we didn't remember to do it, so we have to fix that. See what we are supposed to have. Yeah. So we have to go back into our 3D model, because we have to change the material of it. So in the first practice task, we changed it to an aluminium alloy. Now we're going to change it to ABS plastic. So we go up to the very top where it says generic. We click it to open up the drop-down menu. And ABS plastic starts with an A, so we have to go all the way to the top. And we have ABS plastic on the top there. So we select that one and it says ABS plastic in the top line there. And then we can go back into our drawing. In order to put the information about the material in here, we need to click the parts list symbol up here. So this one, parts list. And it now tells us that we need to select a view. And since we only have one part here, that's not a problem. It doesn't really matter if we select the base view or the projected view. It's going to give us the same information. So I'm just going to select the base view in this case. And you can also see that it now shows the location of the part file. So it's in my H server, in my lecture and practice task 2B folders, and then it's the IPT file. So we click OK, and you can see now that the rectangle with the parts list is quite big. So I'm just going to place it here first, and then I'm going to modify it. And it is big because it has a title which says parts list, and then it has 4 different columns with information. But none of the columns have the information that we need. None of them says material. So we're going to double click the parts list, make sure that it turns red as you hover your mouse pointer over it. Double click it so that you get this window here up. The first thing that we're going to do is to remove the parts list title. We don't need to say that this is a parts list. We only have one part. So then we go to this symbol up here, which says table layout. We click it.
You can click it somewhere.
And you see at the very top here, there is a checkbox beside title. If we uncheck that one, we're going to remove the title from the table. So we uncheck it like this. Parts list is now grayed out. We press OK. Now we need to do something with the different columns, because we don't want these columns.
You're going to add a part list. Select view. Which view are you creating a part list for? You just have one view, right? No, now only master.
So we're going to use the symbol over to the left here. Let's see if I can get the name of it. It actually says column chooser when you go for it, so that's exactly what we want to do. We want to choose a different column than what we already have. So we click this one, we get a new window open. And over on this side, we can see the columns that have already been selected for us. Item, quantity, part number, and description. We don't want any of those, so we're going to remove them. So we mark one of them, go to the remove button, we click once, click twice, click 3 times, and then 4 times. We've removed all 4. The only thing that we're interested for this single part is to show the material. So we're going to go over to the available properties part. We're going to scroll downwards until we find material. Then we click add so that it shows under selected properties. And when we click OK now, we have only one column here. It says material and it says ABS plastic beneath. We click apply, and now we see that it's changed on our drawing also. So OK.
You haven't changed the
and now I can move this one, so I can attach it to the lower corner here. So I can drag and drop it. I mark it first, then I drag and drop it down into the corner, and it's going to sort of automatically connect to the corner there.
generic. Yeah. Scroll all the way up and choose ABS plastic.
So we have 2 more things that we need to do. We need to add a notes section, and we need to fill in the title field here. So in order to add a notes section, I'm going to do the same as with the general tolerances note. I'm using the text box up there.
Okay.
Then I place it somewhere in the lower corner here. And the reason we put these ones in is that we are giving additional information to the manufacturer. So I put in a title, notes, and I'll put in my first note, which is that they are going to break sharp edges to 0.2 times 45, and then I need a degree symbol here, and I can get that one from this part. So I go over here, and it's already pre-selected a degree symbol for me. If it hasn't done that for you, you can use the drop-down menu, and you see you have quite a lot of different symbols to choose from. But we want a degree symbol there. So once I click it, I get a degree symbol behind 45. And this means that they are going to create a chamfer along all of the cut edges that is 0.2 millimeters and at a 45-degree edge. Basically, it just means that they are going to lightly grind all of the edges so that they won't be sharp, that we can't cut our fingers on them. If I now wanted to give some additional information here, if they were going to stamp a part number into the part, or maybe I want them to specifically use one method of manufacturing it, maybe I would want them to use a water jet for cutting it and nothing else, then I would put this in as node 2 and node 3 and downwards. But in this case, we only have break sharp edges because we don't have anything else to add here. So press the OK button. I exit the text function so that it's no longer blue up there. And now I'm just going to mark the text box, and I'm going to move it down into the corner. So now the only thing that we're missing is to fill in the title box here. And when we're going to fill in the title box, we can't do it down here. We have to go into the browser tree. And if you look at the icon beside ISO, it looks like it's highlighted this lower part of the drawing. So that's the one we want. We'll open it up with the arrow beside it, and we want to go to the field text part. And once you're at the field text part there, you're going to right click, and you're going to do edit field text. Then you get this window up. I can't remember if I can expand it, can I? Yeah. So I'm just going to expand it a bit because this is all of the information that's being put into the different rectangles in the title box. And you probably noticed that you can't write anything directly in here. So we actually have to open this one which says I properties. And I would advise you to put it beside the other one so that you can see both windows, because it's a bit easier to navigate then.
Yeah, maybe still like this one.
And we're going to look for fields where we can put in information, and the fields are going to be named title, part number, company, author, checked by. So none of those are here in the general tab, so I continue on to the summary tab. And there I see all the way at the top, it says title, and it also says title here. So then I want to add my title here. So I'm going to put in plate with holes. It says author also here, and I have author over here, so I want to fix that one also. I would advise you to put your student number into the author field. You have to do that for your submission, because I need to have your student number in the title box. So I'm going to put in my student number. And then we also have company here, and we have company there. So we're going to fill in company. And this can be an imaginative company. So maybe your name incorporated or something. Or you can just, if you're not all that imaginative today, you can just put in HSH for this school. Now we don't have anything more on this tab that we can fill in here. So we're going to continue to project. We have part number. Now if I had been wise enough to actually save this drawing before I started doing this, part number would already be filled in with the name of the file. So now I'm just going to put in a plate with holes. We also have revision number here, and we have revision number there. And the revision number is to show that if you at a later date return to this drawing and you change something, then you're going to change the revision number also. Because then the manufacturing people will know that this drawing has been changed. I can't do it like I used to do. I now have to follow the new drawing. So if you change the diameter of the holes, if they're supposed to be 21 millimeters instead of 20 now, you will have to change the revision number also. Usually companies will either use alphabetical or numerical. So either it will be, for example, we start off with an A, or it could be 01. And then for the next, you would use a B or 02. And I've actually I've seen drawings where they used numbers, and they were up to revision 49. So that was a drawing that had been heavily changed over the time. But it was also for a product that was over 20 years old. So there is no more in this project part. So I'm going to continue on to the status tab. And here I get the checked by and engineering approval by. So in this case, I'm going to put in the initials of Torbjørn and the initials of Einar. In an actual work situation, this wouldn't be filled in until one of your colleagues had actually checked your drawing. So when someone had actually checked the drawing, they would fill in their initials for the checked by. Then the drawing would be sent to an approver that would also check the drawing, and then they would fill in their initials. So it's a much more detailed process out in a company. But here we're not actually going to produce these drawings, so we don't need to follow these rules, strict rules. And then we're going to put in a check mark for the approved date for it, because that's going to end up in here. Now we've gotten all of the information we need, so we can either click the apply or use, or just directly on the OK if we want to. And we'll see that it's now filled in everything. Once I click OK, I have everything that I need here. So I've got the name, the part number, I've got the company, I've got my student number here, I've got Torbjørn's initials there, Einar's initials there, and then the date of approval. I also have the date of creation for this one. And then I have the revision number down here. So if I next week went back to this drawing and I changed the plate thickness or I changed some of the dimensions, I would also have to change the revision number for it, just so that it is very clear to the manufacturer that it has been changed. And now we'll need to save, or else we're definitely going to lose this. So I'll click Save. It fills in plate with holes because that is the name of the part file. And that's okay by me to use. So I click Save. Then OK.
Sorry, you want to do what?
So now it's completely saved. And I am safe if Inventor chooses to crash right now. So, which it sometimes does. We actually had it happen yesterday with, or was it last week, with one of our students. He had done quite a lot of the 3D modeling, and then suddenly the computer Inventor crashed on his computer, and he had to start over again. So even though I usually don't remember to save while I'm working, if you can remember it, it is important that you actually do it also, so long as you can manage to remember it. It will save you a lot of work.